Ellipse, the shortcut. This is another way that you can plot a foreshortened circle. Honestly, this is how I do it mostly day to day in my real life, and it works just fine. But I felt that sharing a more accurate mathematical method would serve you in your life as an artist. Okay, so for this one, we start the same. We need to find the center of this square. So we're back to our diagonals. Our next step would be to connect our vanishing points through this center point in order to give us 4 quadrants. Four quadrants. Now, again, we should make note of our points of tangency because those are going to help us out. We got this edge and this edge, this edge and this edge. Okay. This next part is going to involve a little bit of eyeballing. Within each quadrant, we're going to be working along the diagonal. So that's going to be this line, this line, this line, and this line. What we're doing here is we're going to divide each of these lengths into 3 equal segments. You're just going to make a tiny mark. So first, look at it. When I'm dividing something into a complicated fraction or anything harder than half, I think of the situation where you have friends and someone gets to cut the sandwich into pieces and then someone else gets to choose. So you want to make sure everything's even. So we're cutting this length into 3 equal pieces. I see this is about a third. It's about a third. You could measure it. In real life, you're probably going to just eyeball it. That feels like thirds. I'll do this one now. So when I'm covering this up, it's just to kind of like let myself focus on one thing at a time so I don't see all the other lines. I think I got them. All right, we need to do the same for this one and this one. It's going to be a little harder because it's a shorter line and we may have a tendency to look at it on that angle. I think it's here and here. Maybe a little closer. All right, last one. Okay, so we have thirds, right? Now, here's the cool trick. The outermost third should become a point at which we will plot our ellipse on. So make a note of those. So similar to the first method, we gave ourselves 8 points to connect. We just found them a different way. Here we go. It's time to draw our ellipse. Remember, no pointy edges. So for Jenny, that means starting with like a little parenthesis mark. Because this is less precise, it's probably going to need a little more correction. But it's a starting point. All right. I think I have kind of an egg. This feels round and this feels pointy. Wondering if this guy comes past. Okay, let's just see what we got here. The truth about a cylinder, by definition, is that these vertical edges need to come and connect with the top of this second ellipse. I am going to use that info to help me correct this top ellipse. So if you use your right triangle and you connect to a trustworthy horizontal, which I really feel like my horizon line is the best one for that. I want to line up to the ellipse that I believe in, which is this one. And I'm going to come up to meet this central diagonal. Cool. We're going to do the same thing with this side. So I'm trying to make sure I'm at 90 degrees to my horizon line. Okay. Again, I'm coming up to that center line. All right, so things we've learned. This fellow needs to be a tiny bit wider, and maybe that's because I didn't cut the sandwich great, and maybe that's because a human drew this and not a computer. But what we would do is connect them. Okay, so now I know I'm going to hit that point and that point. That looks better. Okay. Let's see how our minor axis looks. So this should also line up to a perfect vertical. So I'm checking it against my horizon line. And I'm connecting the center of our bottom square to the center of our top square. Looks pretty good. I'm going to draw that in with red. Oh. And if I keep going, this is our minor axis. Let's just take a look at our major axis symmetry. So I'm again going to trust this central plumb line, which means that's where I'm putting my triangle. All right. So again, the central axis is not going to run exactly through the diagonal. It will be parallel to the diagonal, but it's going to be a tiny bit forward. On this top ellipse, it will be closer to our diagonal than on the bottom, and that is because this ellipse is more foreshortened. Okay, so everything is just closer together. So I got my major axis and my minor axis. Let's find our major axis on our bottom ellipse. Starts the same way. Taking a perfect horizontal. So sometimes it's tough to call, right? Hard to say where this gets the widest. Here's how I do it. I will slowly slide my horizontal through that shape, coming down. And what I'm looking for is when these edges are at their widest point. So like, as I come down here, I notice that my shape is getting longer as it hits this edge. So we go longer, longer, longer. Seems pretty wide. And then where it starts to turn back and get skinnier and skinnier, that tells me I gotta go back up. So I'm just kind of sliding and looking for the widest point. I think it's here. Want to make sure it's horizontal. Okay. Seems pretty good. That's a little hard to see, right? There we go. Great. We've got 2 foreshortened circles here, 2 different ways. I've indicated my minor axis and my major axis of each one. So this half should be symmetrical to this half. This half should be symmetrical to this half. Same down here. All right, there's your cylinder.